Good morning, good afternoon, everybody. Uh, I think we have a very, very interesting panel here, and uh, 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 a depth of experience and diversity is quite unique in this panel. Today, India is seen as the next manufacturing destination in world, respected. Few latest examples. I think the scale at which or speed at which iPhone production has increased over the last few years. It is a testament to the skill set and potential India has in a broader context. How did we become the next potential destination for manufacturing with such a high potential? I'm going to go back to 2005, Mike Friedman's book, World is Flat. I think that's the book some of us read with the gray hairs and got inspired. Uh, what followed 2005 to 2020 almost was absolute free way of information, material, knowledge crisscrossing around the world, and the product supply chains got intertwined in that entire process. Something changed in 2020, post COVID pandemic. Most of the countries started introspecting their manufacturing capabilities, and that brought a slightly different thinking to what was happening for almost 15 years. Fast forward today's geopolitics, don't want to touch, but that brings in another dimension into the manufacturing. Nevertheless, it reinforces India's position as a leading manufacturer. It is here to stay. We have a tremendous captive market ourselves, which is hungry for innovation, it's hungry for change, hungry for becoming world class. Uh, so, going beyond the introduction of the panel, I would like to request each of you to give a background of what you do and how you got here, and then that will set the context for the audience, and then we move on to the next steps. So, Bhaktha.
Thanks for the opportunity to be here. My name is Bhaktha Keshavachar. I'm the CEO and co-founder of Chara Technologies. So we build rare earth-free motors and matching controllers for traction and various other applications. Just to give a wider context, we are moving from hydrocarbons to electrons for all our energy needs, which is all good. At the heart of every machine will be a motor, and the only way to build an efficient motor today is something called a PMSM motor, which has these magnets in them. These magnets need rare earths, and the problems of rare earths are well known. So we are trying to solve that problem by building rare earth-free motors and controllers. Thanks.
Hi everyone, I'm Gadhadar and I'm from a startup called Nopo Nanotechnologies. We specialize in an advanced material called a single-walled carbon nanotube. These are extremely small tubes, about 2 lakh times smaller than a hair strand, considered the strongest material known. So what we have done is to figure out the technology and manufacture it. So we have indigenized the technology. More than 90% of the components are all, the systems that we build are all from India. And we produce the smallest tubes known. These are less than a nanometer in size. And all of this was developed here in India. And today we have found use cases for the material in batteries. So every lithium ion battery that's coming out today requires this material as an essential ingredient. It's also used for making advanced electronics. So think of transistors that are 30 times smaller than what we have today, which is what some of our customers are buying from us for, and conductive polymers and other areas, especially composites. So that's what we're doing.
Thank you. Vivek?
Yeah, hi, I'm Vivek. I run a company called Sona Comstar. We do 4 things primarily. We do transmissions, primarily for electric vehicles. We make motors and controllers using rare earths right now, PMSM. We make 3.6 million of them, so hard to do in any other way. We have a braking division in which we make brakes for railways. We are India's largest brake system provider for railways. And we have a sensor and software division, which is much smaller. It's about 10-15 million. So overall, we would be close to about $500 million in revenue. And yeah, that's what we do.
Thank you.
I am Rohan. part of Sanlayan Technologies. I'm the CEO and co-founder. We're a 3-year-old defense electronics company with a bunch of deep technology applications. One, we build very high reliability military-grade power supplies for aircrafts, missiles, missile launchers, tanks, submarines. Second, we do embedded computing, embedded solutions. So, things like controllers, processors, embedded systems, again, that go into cockpits, that go into, where the brain of every system that's used in defense kind of sits in. And third, we're now starting to build out our own electronic warfare and radars, which kind of become the heart of new age, modern warfare, as we call it. Yeah, that's about it.
Thank you. So, just to give you a perspective, what Gadhadar is doing is taking product at absolutely scientific level. So, carbon nanotubes. So, purely fundamental research turning into a meaningful product that can go into the market. What Bhaktha is doing is focusing on a product, which is a motor. So refining that, building something so unique in the market. Rohan here is looking at a product in a very integrated fashion. Also, one of the statements he mentioned while we were chatting is they are 3-year-old startup in a business of buying companies. So that's quite unique. Absolutely. So that is a very unique perspective. And we have Vivek here who operates 14 manufacturing facilities around the world, operating in India, US, China, and few other places I don't know of. So there is a wealth of knowledge or the entire ecosystem on how to rise from a fundamental research to producing something at scale in the world, winning the trust of global customers. So I would like to start with you on a fundamental research to product journey. Little bit of background, why do this? How did it come about? And what has been your experience so far?
Yeah, so with nanotubes, the journey so far has been 14 years long. And it started out as a passion from high school. So I've always been interested in space, used to see rockets take off, and then used to ask the question like, okay, how do I get to space? What is needed for that? So one answer I found was space is very difficult. And even today, if you look at it, there have only been 600 people who have gone to space. The reason being the rockets we send up, they're like at the extremes of engineering. So things can go wrong, just like things happened yesterday too with one of India's rockets. And that's not unexpected. That's a risk that's taken to go to space. So the main reason for this is because materials and the strength of materials. So it's only so much that you can do if materials are natural and you can what nature has provided with us, which has been amazing, but it can only take us so far. So the requirement was we need to create something that's much stronger than anything that nature has created. And one way of doing that is by studying atoms, and one configuration of atoms is to have carbon atoms together. That's the strongest configuration of atoms that we can think of. So that kindled an interest in this. And it started out by looking at, okay, how do we make nanotubes? So I studied, I took up electronics because that was the closest I could find to nanotechnology. And I realized that there was still a lot of problems and I still couldn't get all the knowledge I wanted. So went and did a master's to study more about nanotubes. And then realized that there were only a few processes that seemed promising. And one of them had been a work that had been done at Rice University. So I looked up the professor who had worked on this and tried to connect with him, but unfortunately he had passed away. So then I found his PhD student who had done his PhD on the topic. And the first thing he told me was that I was mad, that see, you're trying to make something. And I told him I wanted to do it in India. And he said, you're more mad now because one is you're trying to create something that's fundamentally extremely difficult. It's not easy. And you're saying that you're going to produce it in a place which has no legacy of creating these materials. Because most often, if you look at technology in India, it has been something that we get as a technology transfer after it has been there for a very long time. It's not something that we get as cutting edge. And that's what every country would do. Like, who would want to give the latest cutting edge technology to anybody else? So it's always going to be their proprietary thing. And so there's no ecosystem, there's no nothing backing this up, there's no investment, there's no funding, and you have no experience. So how are you going to do this? So I said, I'll still give it a shot. 10 years of my life, I'll put it on this. Whatever happens, I'll give that. In case nothing happens, I'm from Bangalore, I can program, so there's no problem. So that's how we got started. And it was about trying to take meaningful steps. Like initially, it was about the reactors itself. So only thing we knew was what Kelly had seen in his PhD was that certain temperatures and certain pressures and conditions could produce nanotubes. This work was tried in the US. The professor, the Nobel laureate, he had gotten significant funding from the US government. They tried it and then they abandoned it, saying it's impossible to control this. That's when we started work in Bangalore. Now, so it took a lot of steps, figuring out how do we build the systems, and then figuring out how do we build vendors and the ecosystem also required for this. And we went through a lot of things that did not work as expected. Many things failed, but we just continued doing that again and again. And starting with a few micrograms, we are now reached kilogram capacities. Like this month, and we are launching our commercial line. And about 3 years ago, I found my co-founder Arunima, who's in the audience, and she brought in the business side of things into the company, like complete technology, and that was just like I was just obsessed with making nanotubes, and she figured out how it could actually become commercial. And so that's how our journey has been so far.
Yeah, thank you. One underlying point here for all the future founders is he has a plan B. He can code and find the work. So that is absolutely vital. That reflects my journey also in the past when I started off. My sole confidence was that if all fails, I can go and find work. I think that's very useful. And whatever stage journey on you are, such a reassurance of your capabilities provide a lot of confidence to take higher risks. So important point to note. Coming to you, Bhaktha, you're trying to, so electric motors have been a focus area since so many years now.
200 years.
200 years, absolutely. And more so in the EV revolution and everything that's happening. Now you are trying to create something which is so new without rare earth material, building an electric motor, your journey.
Yeah. So I have an electronics degree, and my expertise is hardware and embedded firmware. I didn't know anything about motors till about 6 years ago. Thought they were these round things with a shaft coming out. But the biggest impetus for me was I believe that climate change is the biggest threat to this mankind. Maybe not everybody believes in that, but I do believe in that. And we need to fix that problem. And one way to fix it is going electric. Electrons is our source of energy. And that's how I started. And then we looked at the various subsystems in a EV and various other electrical generation and transmission and other opportunities. We looked at batteries. Batteries is $1 billion problem, I think. I cannot raise that much money. And then we looked at motors, and that's when we saw that every motor in this built in this world today has those magnets, NdFeB magnets, and this needs 4 rare earths. And we started this about 6 years ago. The problem was fairly well known, and we decided to build rare earth-free motors and controllers. The second thing was we, as you can see, I'm old and bald, and so wanted to do something that has not been done anywhere in the world yet, just as a feather in the cap. And the third one is we also wanted to make this electric transition successful. And there are 2 problems, I think. Primarily, one is cost, and the other is what Vipul was telling. I think the world is different today. There is deglobalization happening, and we want to solve the problem. That's how I ended up with starting Chara. And as I said, I didn't know anything about motors. Found 2 co-founders. One is he was head of design for Kirloskar, a big motor company, and the other co-founder is a graduate of IIT Madras. He is our algorithm and hardware expert. And last thing I want to say, Ahmedabad Ventures was our first institutional investor during COVID. He's standing right there, unseen, they invested in us. So,
Fantastic.
Glad to be here. Thanks.
Rohan, I still can't get my head around a startup set up to buy companies. Thought process. I think that's so unique. And what were you thinking? What's the plan? How did it all come about?
Yeah, so Sanlayan actually means fusion in Sanskrit, comes from the root Sanlay. And so we were always going to do what we are trying to do. I think the real origin story was that all three of us co-founders in our previous assignment at a large manufacturing company did a couple of acquisitions each, did a couple of large business building through existing founders or companies that were already there, but didn't have the necessary means to address the market gap. And so that insight really led us to saying that there are a bunch of sunrise sectors. Some of them have been sunrise for very long. Some of them are real sunrise in India that have clear gaps when it comes to the supply side, where demand far outstrips supply. And so instead of trying and creating new supply, is there a way to meaningfully supercharge the existing supply that's there, the broad MSME base or even deep MSME base that India has, and see if we can actually use that to be a leapfrog or a jump off point, because we had done similar things in the past, and especially in defense where typically, right, when you look at consumer applications, so I used to run a consumer electronics manufacturing firm before this. You have a TV or a phone which you keep changing every 1, 2, 3, 4, 5 years. But when it comes to exquisite defense platforms like aircrafts or tanks, you would have the airframe, let's say, of an aircraft actually being in service in commission for 3 or 4 decades, right? And when you have such a exquisite platform that you've paid, let's say, $100 million for, the airframe kind of can't be changed because then you're changing the whole aircraft. But the electronics inside actually undergo 2, 3 generations of upgrades. And so that's how we thought that this is probably an area where there is significant work for a young India. And by young, I mean, in terms of being technologically sovereign when it comes to defense technology and applications. For us to actually do. And when we started talking to consumers, it became very clear that the broad base of MSMEs in defense, I think it is between 8 to 10,000, is clearly unable to fix the gaps that now have been imposed by the government, because the government said, yeah, 200 crore ke upar you can't import, right? But there is a requirement for aircrafts and there's a requirement for missiles today. But given how Indian industry was, let's say even in sectors like EMS, auto before that, you can't build capacity overnight. You can't build technology overnight. And what that means is that existing players typically don't have what it takes, whether it is ability to attract talent or capital or even the energy that is required for a company that's been running for 40 years at, let's say, snail space, only doing MRO or doing just niches of work that's available. When you have a French or an Israeli system, what typically happens is that that French or Israeli system ka OEM doesn't want the Indian partner to even open it and replace a screw. They want it to go back to France so that he can get back 2, 3 times of the sales cost. And so that means Indian MSMEs didn't have, they had great, entrepreneurship, and they had great amount of resilience to keep kind of working on that. But this new challenge which has kind of come up required a new kind of energy, required a new kind of thinking. And so that's really what we thought about. Okay, let's raise risk capital, as they call it, venture capital, to build out this kind of an ecosystem that really solves for the customer's problem at large. How can we supercharge, super accelerate the journey of companies that have been around 20, 30, 40 years, create a real, second gen for those companies, create a new fresh of, energy and life and innovation for those companies and the customer. So that's how Sanlayan was born, and we're young in this journey. It's just, starting out. So let's see how it goes.
Thank you. Thank you. Coming to you, Vivek. So, large business, 14, 15 plants, supplies into automotive significantly, forging. Underneath, there is an entire journey of innovation, making near net shape gears or absolute net shape gears to autonomous robots. Tell us.
Yeah, so let me first start by saying that, I mean, given that there are three founders, I'm the only one who hasn't founded anything. I found a business and then I ran it. I hope a little bit better than it was being run. But the first start, we had a fundamental advantage that we had a technology to make a 2000-year-old product, not even 200, which is a
Correct.
gear in a very different way, which makes it cheaper and better. And if you have something that's cheaper and better, very low likelihood that you will fail. Now it's just a matter of scaling it. Scaling it is basically a bandwidth and capital problem. It's not really a engineering problem anymore. But can you innovate and use that flywheel of a product that is so good that you will always have growth and keep getting healthy cash flows? Can you use that flywheel to do other things like get into motors, get into railway brakes, sometimes organically, sometimes inorganically? Like he said, the question is that if I'm going to get paid back after 8 years, let's say, and organically it takes me 7 years to get to first dollar of revenue, then I can't get paid back in 8 years. I might as well do it inorganic. In railways, that's how the decision was. To go from component to system, subsystems, if I have the capability to make gears, make the whole transmission. Why not? We have done that for the last, I think, this is my 11th year running this company. So we will be probably 12 times in 11 years is what we've grown. In revenue terms, profit terms is infinity, because when I joined, it was loss making. Because of debt, not because of other reasons. It was a great technology, good asset with really bad financing. So if you can fix financing, you can solve a lot of things. I graduated from here. None of what I learned was applicable. Uh, because nobody teaches you how to take a company whose debt service is higher than its EBITDA. How do you make that possible? Nobody teaches you all of those things. Uh, God's been kind. A lot of the big bets we took paid off fairly early, which is why we got the financial freedom after 2-3 years of running it. We got it from 350 to about 500 crores, paid off all debt, and that's when we got the freedom to actually incubate tons of ventures underneath that umbrella, because it was our own capital and it is permanent capital. And then I only have to worry about payback and how many things can fail. So you create optionalities. I mean, most of the audience is founders, and which is what I try to tell founders, that don't get stuck on one idea, one device, or one product. Create optionalities that can give non-linear returns in the future, and the cost is non-fatal. Cost has to be low enough that if you fail, it doesn't kill you. Your business has to continue. I mean, if I look at the three people, all of them actually span the entire taxonomy of technology. Technology has three variants, right? Technology mimics nature quite often, because that's what human beings are most comfortable with. Fundamental, which is you take a scientific phenomena and you try to make a component or a system out of it. Combinatorial technology, that you take a bunch of different technologies, radar, electronics, FOC, software, and try to make a better system out of it. And then, of course, the vertical stacking, that can you keep going from component to subsystem to system to assembly and make the final device itself. And within this group, I think we have all of them. We also do all of them. But that one flywheel, if you can build, that gives you healthy cash flows. I think a very underappreciated thing of running a business is, when you make anything, any product, when you manufacture, getting to that first build is not as tough as people will tell you. Yes, the foundational stuff is tough, inventing something. Getting the first proto, not that hard. Getting that first proto to TRL 6-7, which is you make it commercially viable, that the price is attractive enough for someone to buy it, that's tougher. Making that first thing and getting it on the road, slightly tougher. But making millions and making healthy cash flows while doing it for decades, that is extremely tough. So when you get there, do not let that ever get diluted, and take whatever you can from this. Use this as your flywheel, like I say. A lot of startups use this word flywheel. I don't think they understand it once, because it is a rotating device which stores energy, which we make, so we know what it is. But that's why I'm using that analogy, because we make the product. A flywheel is the most brilliant application. And then, like what he has done, Rohan's done, he's actually bought two flywheels, which, if his hypothesis works, will give him enough cash to fund his next two acquisitions. And if they too turn out to be flywheels and not money sucking traps, he can keep doing this, and you can keep building out. So that's what I've learned in the last 11 years of building this company.
Wonderful, wonderful. One underlying theme out of the little humor he did, that what he learned at IMA didn't really solve all the problems. A degree from elite institute is not prerequisite for founders. It can be done. It's not a barrier. Wherever you're coming from, you can still do it. So that's an important point. Going forward, I'd like to touch base on three key topics. One is government, second is people, and third is governance. Right? So we'll start with government. So as a business leader, Vivek, you know it, I have known it all my life. We always have a long list of things we want government to do. Policy reforms, this, that, this concessions, PLI schemes, and so on and so forth. Rarely it happens in the time we want it. It does happen, and it happens at its own pace. So every founder, every business leader has to figure out the way of growing and thriving in spite of, not because of, right? So how each of you are approaching this? Some policies are helping you. Some policies you want it, but not happening. But in spite of all of that, you still decided to start something, grow something, build something, and take it to the next step. So starting with Bhaktha.
So, where should I start? So, we are building, we believe, is something strategic, something very important, and we thought the government will help us. The government did help us in a small way. Our first funding came from the Indian Institute of Science. I think the money came from the government. So there is a little bit of support. And now when we are going into production, we are shipping a few hundred motors a month now to various customers. We have approached the government to be completely fair. The government has also approached us. We actually got calls from Delhi saying that they come and help us out. Vivek knows we were in common meetings. The only thing we ask is that for critical technologies like this, energy is critical for us as a country, as a society. I think the government should support us, like what Vipul said, a PLI scheme or a FAME-like scheme. We should do that. But having said that, we are building our business even without that kind of support. But on the positive side, I think one thing I want to point out is that India is a big enough market now that we can actually build a product and deploy it and then take it to the rest of the world. So there is one advantage. Since we are speaking of government being in the startup ecosystem for the past 15 years, I think generally things have become much better. Governance help and capital is not easily available, but it is available. So that's my view of the question.
Thank you.
Yeah. So I think government, they have their own role. It's like both good and bad. Like as long as it's not regulated, it's like good place to be in. And so it's like you don't want to get on a radar to get regulated. So it's as long as we don't do that. Next is when it comes to any kind of funding too, what I've seen is, at least in Indian context, it's also that any government money, it's like accountable for the people, which means that you have to have social benefits coming out for any money that's put in. So that's something that came to us too. So the pitch from me would be like, okay, this is more strategic. Like you have the strongest material. Look at history. Everyone who has the strongest material becomes the strongest person. They become the developed nation and all that. But that didn't cut it with anyone. It was more like, okay, can you find an application that people can connect with. And then we found that there's a use case in water, and then everyone started helping, like, okay, water is good, it's better than strong materials. So it's like, okay. So, but in a different Western context, the strong material sells much better than water. So that we've continued developing on those lines too, so adapt to that. And some of the new programs that have been announced, they look very good on paper. So we'll just have to wait and see how the implementations happen, especially the new funds for deep tech and the implementation. I think that sounds very exciting on paper. Let's see.
So I have a slightly different take. I think we are at that stage that we should be asking what we can do for the government rather than what the government can do for us. We are a poor country. The government has many, many other priorities. If I look at my own background, I'm here today because of what the government enabled. My engineering college fees was like 15,000 rupees per year or something. I think my mess fees was higher than my tuition fees. IMA, at least till our time, Kunal standing at the back, till our batch, it was heavily subsidized. It was like 1.5, 1.6 lakhs or something for a year. All of that came from the taxpayer money. So the government funded building me to a person who should now be capable, like we do for our kids, that hopefully 25 साल के बाद तो कुछ दे दे यार. Or do you keep funding them all their life? Give them PLI, give them incentive. मतलब cradle to grave you support, government will support you. We are not a communist country. We are socialist. I would say business, especially large business, owes a huge responsibility to help the government. We try in a little way. We partner with IMA Ventures to give grants to companies. Every year, I think we give grants to 2 companies here. In IIT Delhi, we do the same thing. Because I have been working now for the last 5 years with a lot of people in Niti Aayog, in the Ministry of Heavy Industries. And if you look at the fund allocation and how many areas they have to deploy in, and you get the bureaucrats' problem of how many people come to them and lie outrightly. It is tremendously difficult. Most of the government schemes, people will cheat the government. That's the first thing. We are also not a very trustworthy people. India is not a high trust society for a good reason. You look at FAME 1, it failed because the companies cheated the government. FAME 2 failed because companies cheated the government. When the next PLI for EV comes, obviously they will put 100 barriers to it. And I don't blame them. If I were a bureaucrat, I would have done the same thing. So when I work with them, by the way, the R&D thing in Niti Aayog, that policy has come because we advocated from the industry very strongly for that there should be an R&D fund and it should be inclusive. As long as you are open and not selfish and you're only talking about your self-interest, there is a huge willingness to listen. There is a huge willingness to formulate policy which specifically addresses that very need. We will have a rare earth magnet policy has been announced. That is only by lobbying from only 4 or 5 of us who actually need the rare earth magnet. I'm India's largest rare earth magnet consumer. We pitched, and within 4 months, we have a policy out and $1 billion outlay. So if you actually, which is a material, which you said that they're not interested, they are interested if you actually tell them what happens if you don't do it. But you have to be upfront and talk about nation, not yourself. Only then will it resonate. So I would say my experience has been kind of opposite. Given the constraints, if you understand the constraints a country has in the welfare schemes to everything that they have to fund, yeah, and I mean, if everybody here paid the taxes they were due, we would probably have more money to allocate. But people have to pay taxes also.
True. Rohan?
Yeah, I think I'll have to go with what Vivek said, right? In my current assignment, पहले तो the government is the only buyer of defense, तो मैं उनके खिलाफ कुछ भी नहीं बोलने वाला हूँ. Right? Whether I sell to a private company like L&T Defense or whether I sell to Indian Air Force directly, consumer तो वही है मेरा. तो consumer मेरा भगवान है, कुछ नहीं बोलूँगा. But I think like Vivek said, right, and I've seen it even in my last assignment where, for example, I've seen firsthand what happened to EMS in India, right?
Yeah.
And how it evolved. I think there's a learning curve that we need to allow even to the people who are trying to solve this problem from the outside. They rely very heavily on inputs that come from the people who are on the inside trying to build, whether they're operators, whether they're end users and customers. And I think more often than not, and it's now clear across so many sectors, semicon, pharma, auto, consumer electronics, defense now, is that there is a real willingness for them to understand, what are the critical stage gates that are required for industry to progress, for that technology to mature, and there's a willingness for them to, allocate capital. There's a willingness for them to kind of innovate in terms of how they can create new procedures to allow, like Vivek said, ke, how do you ensure fraud कम हो इंडिया में, हो नहीं ये तो हो नहीं सकता, but कैसे कम हो सकता है fraud? How do you ensure that the right people get the money? And so that's something that I see in defense a lot. And in fact, in defense, what we are seeing is very, very strong tailwinds. Like I said, it becomes very difficult, for example, for the Air Force chief, who is short of, let's say, 10 plus squadrons, to even import aircrafts, because the government flat out said 200 crore के ऊपर आप import नहीं कर सकते हो. And that's actually fillip to Indian industry to come up and say, yaar, is there someone who can, at the right cost, at the right time frame, build aircrafts for India? And those are like multi-billion-dollar opportunities. There are a few countries and a few OEMs in the world who build aircrafts. The government is doing whatever it can in terms of saying, yaar, we've seen that model succeed in a couple of industries. Can we actually replicate that? And I mean, not so far away is there is Adani, right, who's kind of taking those steps. So I think the groundwork is in place. It's WIP. India is like a khichdi of half of Europe. It's tough to gather political will. It's tough to gather resources, like Vivek said, for a poor country. But that's where people like us come in. That's where private capital comes in to kind of bridge the gap, to ensure that incentives are aligned both for the government, whoever's the end user in India, and for the people that are kind of building for both the government and end users. So I think that's my perspective and what I've seen, at least in my last two big assignments.
Super, thank you. So I think circling back, in spite of that, it can be done. So before we jump on to people topic, couple of things. We have about 15 more minutes. So I would request all panelists to shorten their responses. On the people side, before I jump on to the people side, I want to come back to you, Vivek. You produce almost 9 or 10% of the gears of the world's requirement. That's a lot. So you're dealing with most demanding, most respected, most difficult to serve customers everywhere. How do you win trust of those as an Indian business? I think that's a lesson for every founder, quite vital.
So the moment you talk engineer to engineer, you're no longer an Indian business. I mean, when engineers talk, as engineers in the room will know, their language is different. It doesn't really matter. There is hardly any cultural baggage in engineering. And it is a very heavily engineered products. We hardly ever speak to purchase people. That's the best business to be in, by the way.
Correct.
Purchase people are not nice, irrespective of who they are. So we make about 52 million gears. We almost 9% of vehicles in the world will have something we made inside it. If you make a great product which is cheaper, better, and more reliable, I don't think you need to know anyone or have any culture. It doesn't matter. Just your product should be ambassador. If you can build that, you don't have to worry about who you know. It's only what you know, and then it doesn't matter. That's it.
Super, thank you. Coming back to the people topic, most vital a part of success of any business at any size, any scale, particularly for the startup. When a founder goes out and builds a company, usually first day is I, me, and myself, three of us in the office. That's what the first day looks like. And then you go out, try to find an investor and a team at the same time. Investor asks for the team asks for the investor. Do you have an investor? Then I'll join. An investor says, do you have a team? Then I will invest. All three of you in a startup phase, you'll have your perspective. And Vivek, I would like you to comment on how do you manage thousands of people starting with Bhaktha.
So, so when we started Chara, it's fairly deep tech because it was being attempted for the first. Reluctance motors are known, but nothing is deployed yet anywhere in the world. We were one of the first few ones to do it. It's so one thing we made sure is that the founding team, which is myself, Ravi, and Maha, had all the capabilities to build the product, at least the first version. I wrote the code, Maha designed the hardware, Ravi built the motor. That's how we solved the problem. But then the question came about of scaling up, and that's where we found that it's very hard to find core engineering people in India. A lot of people write programs, Java, C, or whatever. Nothing bad about it, but core engineering, right? Electromagnetics. There is this thing called Maxwell's equation. I think very few people understand. I never understood. Then there is, heat transfer, hardware, algorithms. The way we have solved that problem is it's just what I found also that worked in my previous startup is that hire from tier 2 engineering colleges. Again, nothing wrong about tier 1 colleges. Tier 2 engineering college or even tier 3 and train them. It's just that the hit rate is less in the sense that if you hire 5 people, 2 of them will turn out to be superstars. Needs about 6 months to 1 year of training. You just have to, while interviewing, just see if they're hungry, they have a chip on their shoulder, and they can speak well, and they know their basics. Few questions you can tell, and I think that's how we have built the team. And the second part is, and again, because of this whole globalization, people are coming back. We have PhDs from well-known universities like Carnegie Mellon and Vienna University. People are coming back. I think that should also help us in building people.
Super. How do you find people in a nanotechnology?
So what I've found over time is for getting really good people, what is required is that the person has spent at least 10 years on one area and has become really good at it. Now, in India, nobody stays for 10 years in one place. So everyone's like jumping around every 2-3 years. That's kind of become a norm. So getting an expert in that becomes difficult. Now, the thing is, anywhere in the world, this is the norm. So what I've started realizing is like the cost of developing technology in India versus rest of the world, it remains the same. It's not really different. And even when we get people coming back, they still expect to have the same dollar salaries being paid here. It's not any different. So that is always going to be there. So the cost of developing, we just can't say that it becomes cheaper doing it here. Maybe operations could be marginally lesser. But everyone aspires to get more. And I keep thinking the other time we had been to Japan to visit a few customers. And we saw one top-notch professor moving to China to work there. And that's effectively like someone from India getting a 1 crore package in Pakistan and moving there to work. So, and that will also happen here. That I'm sure, like if a 1 crore package comes in, college offers, and the workplace is Karachi, people will move there.
Correct.
So that's something that's a reality. It's no longer something where people will be like very patriotic and say, okay, I'm going to work for India, do it only in India. That's very, very little. And very few people have that thing that, okay, the country has given me so much, I need to give back. That's a rare commodity now. So that's what I see. So the cost becomes high. We have to pay that cost. We have to get the experts and the best, and then make sure that we get the markets right and scale while keeping the profits and margins high.
Vivek?
So I'll answer a different question because it is obviously scale slightly different.
Exactly. It is how do you manage the large?
We have about 6,500 people, so it's a... So one, hire people who are way better than you. That helps a lot. Like I have at least 6-7 people in my company who can do my job easily. And there are at least 500 people whose jobs I cannot do at all. I have no knowledge to do them. Which makes it slightly easier because you have so many capable people on your bench that it becomes easier as the leader. But very surprisingly, what Bhaktha said is how I actually hired. We have very, very low attrition, by the way. So, like I just completed 10 years and I realized that I am still called new in my company because a lot of people have been there 25 years. Uh, the top 5 levels, N to N minus 4, attrition rate has been zero for the last 7 years. So we don't actually have that much of that problem. But when you hire, we are very careful. So we are very strong gatekeepers. Hunger and that chip on the shoulder is very, very important to hire for. Third thing I would add is middle class soul. I don't know how to define it, so don't ask me. Basically, abhi bhi sabun khatam hota hai, so you add another sabun or not might be very close to that. Or shampoo mein last mein pani milate ho ki nahi milate ho. Are you still basically not entitled? We can, even in places like Serbia or US, when we hire from people who've come from usually tier 2 towns. I myself from eastern UP, I'm not like from a big city, who have seen the value of money. They are far more responsible with the capital you give them to spend on a project. That sense of responsibility, zimmedari ka ehsaas hona chahiye. I find that lacking a lot, which is why we spend a lot of time before we let anyone in. After that, I think retention becomes easy. And this chip on the shoulder thing is absolutely bang on. If you don't have anything to prove, very unlikely you'll do anything out of your way for the company. So yeah, that I guess it doesn't change with scale, that answer.
So, Rohan, such a young stage, you have your team, you are acquiring a business, so they have their teams with tremendous legacy. How do you integrate it all?
I had prepared something else for the answer.
You can
Yeah.
create your question and then answer.
Very contrary to what some of these people said, right? I'm a chemical engineer who studied on the other side of the management campus. I'm Calcutta, then sold cigarettes for ITC. Post that, I was with a logistics company. Post that, I was with Ola for 4 years, then did manufacturing of televisions and now doing defense products. So I'm a bad example in that sense. But what I realized through my own personal journey and having had the opportunity to work at very young companies who were kind of changing the markets they were in and evolving at breakneck speed is what that people are super important. And also I think agency, if I were to be able to distill it, a lot of the things that my co-panelists said is that agency is one of the most important traits, if you can figure out how to look for it, that actually defines whether a person will succeed or not in any given assignment. Now, I'm not saying that I can solve radar equations, but I have the agency to go very deep and understand what is needed, what's happening at the cutting edge or the bleeding edge of that technology, what are the GaN semiconductors that are required, how is the form factor moving, where is the technology going, where are the applications moving. And so really that's what I think is super important, is that somebody's ability to learn, somebody's ability to relearn, unlearn, somebody's ability to just go hard and deep at a problem is all driven by that person's agency, whether they want to kind of figure out how to do it. But I think on the integration point, and that's something as a company and as a philosophy at Sanlayan that is very deep and very core to all three founders and the leadership, is that most businesses at the end of the day are people businesses. Of course, there's a product, and great product, great distribution, great price will do great. But I think having been at some of these companies, early stage, late stage, and seeing how companies transform because of the people that remain or the people that leave, I feel is that you need to respect legacy. You need to respect what diverse people come to the table with, what their baggage is, how their lens view shapes the view of their world, and also be able to have respectful disagreements when the time comes, in open, right? There's an amazing value that I think McKinsey, Amazon have, which is disagree and commit. तो यार कर लो disagree जितना करना है, but once there's a decision on the table that has been taken, whether democratic, not democratic, you have to commit towards making it happen. You can't go back and say कि यार मैंने तो बोला था ऐसे नहीं वैसे करना है. So I think that becomes very important in organizations, right? Because there will always be 180-degree opposing views, and a lot of times these are not absolute things, right? These are not things that will change the direction or the trajectory of the company in a fatal way. It's just that how well aligned is the organization, how well aligned are the people in ensuring that you maximize the probability of success. There is no 0-1 in business, is what my personal learning over the last 10-12 years has been.
Thank you. I think we almost reached the end of. Can we get 10 minutes grace to get some Q&As in? Yeah, thank you. So no more additional gyan from this end. Your questions, please.
Thank you so much for the insightful session. My name is Ankita, and my question is related to manufacturing. Maybe some kind of nerd question, because if we get some idea and you wanted to build a product, now to build first few product prototype, you don't know how the final formulation will work or not work. So if this is some chemical, there are some chemical which our team has finalized, then how we do the manufacturing? Because if we go to the manufacturing or even to the third party manufacturing, there will be a minimum order quantity. For example, they say 5,000 quantity. Then how we address that problem, because we haven't finalized the final chemical solutions to that.
I'm a chemical engineer. Never done engineering in my life after I passed out of those 4 walls. But to that question, because I have 2 specific insights to this. One is, I think if we're talking specifically about chemicals, right? Solving at lab scale is actually the only way to, get it right in terms of saying, okay, is there a specific application? Is there a specific, biology or a molecular solve that I'm looking for? And the routes might be very different, which will come in when you're going from lab scale to pilot scale to manufacturing scale. But the second part of it is also that these problems are real. People face these problems everywhere in pharma, in other kind of industries. And there are now a lot of startups in India who are solving specifically for these use cases, where they're, taking up excess inventories, they're taking up excess available capacity that's, left unutilized, and creating it into lab scale plants where they will actually manufacture molecules, or they'll manufacture chemicals based on what your inputs are. And of course, those will be kind of expensive. You can't really take that commercial to market, but you'll get a validation of what you're building. Does it solve for the application or not? So there are a bunch of now aggregators across industries where they do specifically, like just 3D printing or additive manufacturing, right? There are people who will actually do pilots for you, who will 3D print a part that allows you to, let's say, put it in a test rig or a jig, or do CFD simulations that allow you to ensure that product sahi hai. Now it's just about taking it from lab scale to commercial scale. So I think that's really the 2 things. Figure out at your own lab scale, and then and specifically in chemicals, right? Because the CDMO opportunity in India is huge now. There are a lot of aggregator companies, a lot of specialty chemical manufacturers who are just aggregators, who will take your molecule and help you manufacture. So
Thank you so much. Yeah.
Super. Any other questions?
Hi, I'm Gitanjali. I wanted to know that what's your take on specifically building up and bridging the gap in aviation when it comes to testing products, as well as certain inventory and test benches and facilities which are existing in the industry, specifically with the government and the installations, wherein they would know a specific use to it. They have come under TOTs, technology transfers and all. And that kind of ecosystem is actually being underutilized because it is to a specific platform for which the TOT has come. So we, of course, are talking about the government opening up and the fundings and the hand-holding for innovations. But how do you see that this gap wherein some facilities actually existing and it could be explored further for utilization, specifically backing up, innovations for the ecosystem in India to exist?
Yeah, so I understand the problem. We face the same problem. What government has done in space sector, particularly establishment of InSpace, which has come as an intermediary government body enabling private companies to access the government test sites. And a lot of the space startups are benefiting from that. I can't promise the timeline, not in my jurisdiction, but something similar is already in thought process for aircraft and aviation related products. So let's hope that that comes into place soon. There are tremendous facilities in HAL and NAL infrastructure throughout the nation, mainly in South India. Also, there is a discussion about setting up a regional test labs, which will allow electronics or mechanical or fatigue testing kind of facilities in specific regions. These are all part of the thought process. How soon? Let's hope very fast. Yes. Last question, then.
Hi, my name is Tejas Arora, founder of Nextera. I have one question. We have heard that defense is a huge opportunity, but how do you really actionably tap into defense opportunities? I do a B2B, then I know what is the playbook behind reaching out, selling, and then renewal. But how does it really happen when you work with government on defense? How do you sell your products in defense sector?
I think he sells to people who are big defense contractors. So it is exactly like B2B. So you go to someone like Adani Defense, which our colleague, my friend Ashish runs. You go to him. His job is to deal with the government and the contract system, but the component system is usually bought by aggregators. Then there is also a tender system, which is actually quite an open and digital thing. Anybody with qualifications can bid for it. It's actually quite open. That tendering system is fairly good.
Government e-marketplace GEM, right?
GEM.
Where you can access most tenders which are open tenders, and most of them also have high levels of relaxations for startups and MSMEs with respect to vintage criteria, turnover criteria, and so on and so forth. And I think these are where you have a problem statement that the government already has, and you can supply products into that. Of course, you have to be L1 वगैरह. इंडिया में उतना quality consciousness होता नहीं है, तो L1 T1 कम ही होता है. But if you have something that's proprietary and you think it can make a difference to someone, let's say the army or the air force, I think the best way is to approach them. There are development cells. There's a technology development fund that the DRDO runs that takes in problem statements from all the three forces plus Coast Guard plus Homeland, etc. There are multiple schemes around called the IDEX and the Aditi Challenge, which is for individual innovators or for corporate bodies that allow you to sell proprietary ideas and solutions into defense. So I think there's multiple ways that they procure. It's just about what you want to access. So I think understanding the landscape would be a good place to start. Working with companies who are already doing these kind of things, just having open dialogue is a good place to start. Speaking to scientists from HL, NAL, DRDO, etc. would be a nice place to start to kind of understand what problem statements are, then go after it. Thank you.
Super. We had a fantastic session. Thank you so much, all of you, sparing your time. I know almost all of you traveled this morning for spending 1 hour with us. So thank you so much. Thank you, IM Ventures, for such a super organization of Summit. It's been fascinating. And finally, thank you, all of you.